Hello, and welcome to the Cloud WAF Monitoring and Reporting tutorial. By the end of this tutorial, you will be able to describe the different monitoring tools for tracking application protection and explain how to use the monitoring tools and how to customize them to best fit your unique needs. Cloud WAF Portal enables monitoring your protected applications using various methods depending on user role. It includes a real-time dashboard which continuously displays up-to-date security metrics, Cloud WAF widgets, and Cloud DDoS protection widgets, which we will see shortly. Security logs, which enable you to drill down to security events to understand the threats behind the events and allow security policy exceptions to handle false positives. Periodic reports that keep you up to date with security threats. Proactive alerts that inform you on changes detected in the threat landscape of your applications. The ability to export Cloud WAF events to external SIEM systems. This capability enables you to correlate the service's security events with other measurements coming from different tools or vendors. The ability to view your service plans in one screen that shows service plans, their usage, and utilization. We will review these in detail in the following slides. The portal dashboard displays various widgets that provide visibility into the security service statistics and convey meaningful metrics and monitoring. The dashboard's data refreshes every 15 seconds. The time frame for which data is shown is configurable. The data in the dashboard is fully retained for 3 months. After 3 months, Radware keeps only aggregated data. Customers that want to view detailed attack data for a longer period of time can export the data to your existing SIEM system. We'll discuss SIEM integration a bit later. Attack statistics are based on the security events. The display of attack statistics data is configurable. You can display all your applications, focus on a specific application, control the time frame displayed, and more. Let's review the specific graphs presented in the dashboard and understand what information they display. We'll start with application attack distribution. This graph displays the ratio between the different actions, blocking, reporting, modification, taken against attacks on the selected application. Rolling your mouse over an action displays the different types of attacks that have undergone this action and the percentage they constitute within all the displayed attacks. WAF Summary displays KPI counters on key Cloud WAF statistics. The Application Security Events widget displays the number of security events that occurred by severity over time. HTTP transactions per second displays the number of transactions per second by actions taken over time. Top Application Attack Sources displays 5 top attackers by attack number. Rolling your mouse over a specific source displays attack types. Top Application Attack Hosts displays top 5 attacked hosts by number. Rolling your mouse over a specific host displays attack types. OWASP 2017 Top 10 displays the number and percentage of OWASP Top 10 attacks performed against the selected application. Top Attacked Application displays top 5 attacked applications by number. Rolling your mouse over a specific application displays attack types. Application Attack Geomap displays the geographical regions from which attacks are initiated and the number of security attacks from each. Here are the Cloud DDoS widgets displayed in the Cloud WAF dashboard. Attack Status displays whether the protected applications are under a DDoS attack or not. Top DDoS Attack Sources displays top attacked source IPs by attack volume and rate. Top DDoS Attack Vectors displays top attack types by volume and rate. Top DDoS Attack Destinations displays top attack destination IPs by attack volume and rate. DDoS Protected Traffic displays the attack and clean traffic volumes over time. The Security Events screen displays security events generated by the WAF protection service and enables sorting, filtering, and reviewing each event in detail. Filtering the data displayed can help in identifying a problem during root cause analysis. A displayed event may be further expanded to display additional details. When an event is determined as a false positive, you can allow this event from this screen. Security systems are generating tens of thousands of events per day. Those can overwhelm security professionals and lead them to alert fatigue, or worse, cause security events to go unattended. As a result of this alert flood, many organizations leave the majority of their security alerts unchecked. Organizations need a tool to help them distinguish between large amounts of routine user actions, which have little implication for application security, and high-priority alerts, which are indicative of malicious hacking attempts or may otherwise suggest a problem with security policy configuration, such as a legitimate request being blocked. Radware's application analytics for Cloud WAF service simplifies management of WAF events by taking a massive volume of raw security alerts and consolidating them into a small, manageable set of recurring user activities, which security administrators can easily address and use for rapid troubleshooting. It provides actionable intelligence that can help them resolve security events. Radware's Cloud WAF application analytics works via a process of analysis based on machine learning algorithms, which identify patterns and group similar application events into recurring user activities. Data mapping of the log dataset to identify all potential event types. Cluster analysis using machine learning algorithms to identify similar events with common characteristics. Activity grouping of recurring user activities with common identifiers. Data enrichment of supplemental details on activities to provide further context on activities. Let's review the options under the Settings menu. Security systems generate a great number of security events, which require a lot of time and resources to manage. In order to be effective and efficient, users need to determine when a change in an event's behavior is considered to be significant and therefore requires their time and attention. That's where Cloud WAF's alerting system comes in handy. Radware Cloud is monitoring and learning the behavior of WAF events rate per application in order to be able to detect anomalies. An alert is triggered when there is a high rise in WAF events rate. In order to determine how to configure the Alerts tool so you will always be alerted on what you consider to be significant, Cloud WAF offers a real-time simulation tool that lets you look at your existing traffic patterns of the previous 2 weeks and simulate the attack tool behavior had you used it on that traffic. You can zoom in and out of the graph to view the information in different granularity levels. The blue area on the graph represents the actual number of events at different times during the time period you selected and according to your defined filters. The yellow line represents normalized calculated baseline. The red bars indicate the number of alerts that Cloud WAF would have generated, if any, at any given point during that time. The number of alerts is based on the ratio between the calculated baseline to the current event count. You can play around with the different parameters and see in real time how they affect the number and type of alerts you would receive, thus fine-tune the alert system to match your specific needs. At minimum, you need to select the applications to monitor and the level of sensitivity. Using the advanced parameters, you can fine-tune your configuration to learn behavior according to specific event criteria and more. Alerts are triggered when the ratio between the calculated baseline and the event count over the last event count interval exceeds the configured sensitivity. For example, if the baseline is 50 events, sensitivity is set to 5, and the last event count is 290, an alert is triggered, since 290 is greater than 50 times 5. Users can also set an event flood alert threshold in order to always receive an alert when event count exceeds this threshold. For example, a user can set the event flood alert threshold to 100,000 to ensure an alert is triggered when the event count in the event count interval, 5 minutes, exceeds this number. The alerts are sent to users via emails. A user that may wish not to be disturbed by frequent emails can set a minimum time between emails. Alerts that are triggered during the silent period are kept and accumulated in the following email. For example, if silent period is set to 60 minutes and alerts were triggered at 9:05, 9:35, and 9:52, then an alert is sent at 9:05 and the next email at 10:05 includes both alerts of 9:35 and 9:52. Radware Cloud WAF customers can generate via the Cloud WAF portal periodical reports that provide visibility into security threats to their applications over the last week or month. Reports are automatically generated according to the selected time period and provide an easy-to-read, up-to-date graphical display of the WAF and DDoS protection provided. Reports can be scheduled and sent by email. Customers can set the frequency of the scheduled reports, weekly or monthly, and update the list of email recipients, maximum 10. Here's a partial example of a generated periodic report. Radware Cloud WAF increases visibility by showing changes that were requested on the service configurations from the Cloud portal. The activity log is a scrollable slider that can be accessed from the top right corner of the Cloud portal screen. Each activity is being logged in the system by the following format. Time, the time that the request has been submitted. User, the user that submitted the request. Activity details, the activity details. Activity ID, unique identifier for the activity. Status, the activity status. The Take Action link added to failed activities includes the following. An Activity ID to Clipboard option for customers that want to refer to an activity later on, such as search for it in the activity log or send an email to Radware about it. The Submit Ticket to Escalate option generates a ticket regarding the failed activity to ERT. ERT then handles the ticket and contacts the customer. When saving application settings, the user can see indication of when it was last saved and a link to the relevant entry in the activity log. The service overview displays general information, such as subscription period and number of networks, regarding the purchased service plans. You can see your current service plans, including the remaining time, the usage of applications and network assets, as well as throughput usage over time. The throughput usage information reflects the utilization of the plan for the selected display period. How does Radware WAF integrate with existing customer security information and event management systems? Radware Cloud Services continuously collect detailed security logs to track security events and activities related to a customer's protected applications and networks, and sends all events raw data to the customer SIEM system. The service's SIEM integration capability enables organizations to download this data from the Radware Cloud infrastructure to gain visibility to this data within their SIEM solution, get a complete comprehensive view of security events across their network, be correlated with other security events coming from other vendor systems or tools. Log data for WAF and DDoS events is provided to customer systems in real time in a secured manner. The log data includes in-depth event information, such as the geolocation of the attack origin, details of the HTTP request, OWASP Top 10 categories, and more. Once an event is created, it is reported to Radware Cloud Management, portal, and also optionally distributed to the customer's on-premise logging system, SIEM. Each tenant owns one or more queues for their events, one for events for attacks as detected by the Cloud WAF, and another queue for events detected by Cloud DDoS, according to the customer's service plans. The event queues are implemented on Amazon SQS queuing. The queues are fully isolated with permissions only for the tenant that owns the queue. When a tenant is registered for SIEM services, the events that are generated by Radware Cloud Services are sent to their queues. The customer deploys Logstash, or optionally another log collection solution that can interface to Amazon SQS. Logstash securely connects to Amazon SQS to pull their security events waiting in the queue. Logstash writes the events to a log file or a UDP port of the SIEM system, such that the SIEM system imports the events into the SIEM database. Once the event data is in the SIEM system, users can further customize the way the data is represented using the SIEM system capabilities. Here's an example of integration with Splunk, a common SIEM system, showcasing how data from Radware cloud services can be displayed in Splunk. Here are the steps to take for deploying the integration of Radware's Cloud WAF service with an organizational SIEM. Enable the SIEM integration capability. Notify Radware Cloud Ops that you would like to use SIEM integration so that the feature is enabled. Obtain Logstash. Logstash is an open-source server-side data processing pipeline that ingests data from a multitude of sources simultaneously, transforms it, and then sends it to your favorite stash. Download Logstash from https://www.elastic.co/downloads/logstash. Radware recommends version 2.3.4 or higher. Note: Radware strongly recommends using Logstash. However, other log collection solutions can also be used as long as they can interface with Amazon SQS. Deploy Logstash on a server in Customer Management Network, typically close to the SIEM system or on the same server. Configure Logstash. Make sure events from Radware Security Cloud Services are now visible on the SIEM system. Thank you for your attention and your time. We hope you had an interesting and beneficial learning experience. For any questions, please contact training@radware.com. You may either view this tutorial again or close the browser to exit.